Hey, good afternoon, everyone. Everyone is sleeping now. So I try to make this quick, okay? So
What you said?
yeah. So let me introduce myself first. My name is Pawarit. I graduated in civil engineering in bachelor degree, and now I'm studying data science in master degree in the first year. Uh, So today we listen to so many interesting topics, right? So and as I said before, I'm just a third year, so I'm gonna say you something that I don't have any research topic yet. But today I will gonna share you about some of my project doing with Professor Ramongsak that about smart parking solution, AI forecast detection and management. Okay, so Okay, so first I will talk about what the old smart parking system is. So as you can see that you can see some sensor, right? The sensor they have three parts. First, the sensor one, the display board, and maybe some smart parking. They have some application or some web, right? So something like this you can see. I think it's common, right, to see at maybe some department store or something. But this traditional smart parking system maybe now it have some problem, still some have problem. So the first one is when you set up install the sensor system, there will be maybe they use a lot of money, right, to install all the parking lot because each parking lot you need to install at least one sensor, right? And they require some time consuming to set up and some kind of maintenance. And the second one is scalability issues. It's something that if you want to expand your parking area, right? So you need to maybe install the system again, the sensors based system again. So they can be some kind of challenging and yeah, time consuming also. So for problem here, two main problem here, so we can think of a solution. So we can use computer vision to uh, instead of the sensor. Because computer vision, we have five advantages here. So the first one is cost effective. This means that they don't need so much money, right? Because one camera can also capture all of the parking lot for some space, right? And the second one is real time accuracy. So we can detect continuously all of the 24 hours. So we can detect the real time accuracy. And the third one is it can be some scalable and flexible. So it can adapt to any parking lot layout or some structure. And the fourth one is we can gain some insight from maybe driving patterns or of the parking pattern. So we can gain some insight from the camera recording, right? And the last one is sustainable. It means something that we use fewer device, right? We use fewer camera, we use fewer device, so we don't need to use so much energy, right? Okay, so now I'm going to talk about how I and with Professor Namongsak doing this project. So we decide to first we decide to use the location at the parking lot in front of the 30th anniversary building. So maybe this my right side here at the Faculty of Engineering. Uh, this is two image of two different camera angle, right? So the left one is you can see that the car is aligned vertical. Sometimes you can see on the top the vehicles are overlapping, right? So I think this is not good for when model want to detect car, right? So the right one is okay. Clear detection is mean that every car are separately clear from each other. So the model is when we take a car or vehicle, it can be more accurately. Yeah. So for our project, I decided to create some mapper program. This program is something like we can draw shape fit to the parking lot, so we can tell that this is the parking zone. So this is the parking zone number, right? So we can draw each one. And we do the no parking zone rule. So we can use this system to warn the driver that this zone is no parking zone, so we can warn them or to move their car or something like that. So this two program this two program will store the coordinate data of the parking lot. Yeah. Okay. This is here. Okay, so we also use a YOLO model. We also use a YOLO model for vehicle detection. So it is too much text, so we should
เล่นคลิปได้ไหมกดคลิปได้ไหมมันไม่ได้พี่ว่าไม่เป็น
Okay, so as you can see, the YOLO model will give us some kind of yellow box that okay, this is car, right? It can detect car or something. And our model will include our red dot center at the center of each car. So it will be a represent of each car in where the car is, right? So okay. So now how can we know that the car is already in the parking lot, right? So it's so easy. So we combine our mapper program and this model result to if the red dot are in the parking lot coordinate, right? So it will show us that okay, the car is in there. So as you can see, okay, on the left is the non-occupied one, so there isn't car here yet, so it shows what can. With the next one is occupied, right? Yeah, you can see that the car is already in there, and the parking lot changed from green to red, so it can say it is occupied now. And the third one is no parking. So if this works similar, but okay, this is will warn us when the car is on the no parking, right? Okay, sometimes our model is not detect correctly, so we decide to put some algorithm in there. So we sometimes the model can detect car, right? So we decide to check the previous frame, the previous maybe some 10 frames before that. Okay, there actually a car in there to check. So maybe our program is store our model result, right? So if we adjust, okay, you can see that there is no yellow box, but it will show that okay, there is a car there. And user interface, we decided to include two things. First is a number of available parking space, and the second one is we show the status of each parking lot and the name of each one. Okay. So at first it's PowerPoint, but now I save as the PDF, so there's don't have any clip. But okay, I will explain. And this is the final result of the of my project. So we can have you can see the number here, but number there that how much how many cars are free of each parking lot, and they have name of each lot, right? Okay. And what next? What will happen next? First, we try to improve our car detection model and some kind of user interface, right? Because now the model is not good enough, so we need to create it better. And the second one is we trying to scaling up the project. I mean, we can go to another parking lot, like I think the behind of the parking we have a big parking area one, right? So we decided to do for that area too. And we are trying to combine with the CCTV camera. So because our faculty have many CCTV already, so I think it is good if we combine it together. And the last one, we decided to develop a web application that can show how many cars left in each parking lot in our faculty. So I think this maybe at in the end of this year, I will do it. Finish. Okay. Okay, thank you.